Let's talk about my topic, Mastering Enterprise Complexity with Service Mesh. It is highlighted with a case study and a framework which can be reused. A quick introduction about myself. I am Shweta Vohra. I am a software architect with over 2 decades of experience designing enterprise solutions. And over these years, I've been privileged to work on various projects diving deep into architectural challenges and designing solutions. This particular one is one of such learning that I'm sharing with you today. Before I get into agenda, just to know my audience a little better, with a show of hand, how many of you know about Service Mesh? Wonderful. How many of you are using it in your organizations? A little lesser, but still few hands. And how many of you are using it in production? Awesome. So maybe a lot to exchange even after talk. Let's get into the topic. So we have 3-point agenda. First is Service Mesh introduction, where I'll be giving a introduction on that and foundational features of Service Mesh, and talking about the rapidly exploding space of Service Mesh. On that foundation, we'll be talking about the enterprise case study, which should give you a tangible look into that how these things work together in a hybrid cloud environment. And lastly, we'll be building on this decision-making framework, which is based on my learning, and hopefully it'll give you guidance on that how to practically approach Service Mesh for your enterprises. Now, before I move on, I urge you all to engage in. I truly appreciate it is a session after lunch, but try to engage in because every topic builds on the other. So with that said, Service Mesh introduction. Before going to technical definition, think of Service Mesh as those invisible roads between your services, microservices, or applications you call them. And those invisible roads are not just making the communication possible, but doing it very efficiently. Now, with that, let's get into the technical term. Service Mesh is a low latency networking and infrastructure layer. And it makes the communication between service to service possible through highly configurable contexts which it gives you. One more thing I want to say before I proceed into its features, that it essentially decouples the communication concerns from your application or the business logic. That's the purpose which Service Mesh serves. What are its major features? I like to put features into 4 major buckets. The first and foremost is the connectivity and control. Because whenever you have services, you have to first establish the communication between them, connect them through service discovery, load balancing, retries, and traffic control. So once you have the connectivity established, which Service Mesh provides you, then you go on to the next feature of it, which is security. Now, security is not, we are not setting up any mesh between service, which is just open mesh. We are setting up a mesh where services should be authenticated, authorized, only needed communication should happen. It should not be an open mesh. So that's where the security plays a very key role, and which comes bundled with any service mesh these days. And it is authentication, authorization, encryption, and policy enforcement are the major things which Service Mesh offers. Once you have upper half of this circle achieved, because without this, you cannot go in production. Those who are doing it, they understand it very well. Then comes the observability. Observability, because Service Mesh works with your microservices very closely, it has capability to read all the telemetry, distributed tracing, and gives you visibility into what's happening into the system. Last but not the least, I would say resiliency and extensibility, where I'm putting a lot of add-on features to it, which is like, how do you test the resiliency of these services? How do you inject faults? How do you do dark releases? If you need to do some filtering, rather than doing it in application, how do you do it at your service mesh level? So there are various features which are bundled in these. Fourth pillar of it, which is resiliency and extensibility. Now, service mesh components quickly. It organizes itself into data plane and control plane. Now, if you look at this layer, this is where, let's say, a Kubernetes orchestrator, container orchestrator, where your application 1 service A is running and application 2 service B is running. What service mesh provides you is the first and foremost, we call it service proxy, sidecar, or envoy proxy, various names, but this is what gets injected into your system. That's what it reads, how it reads your services. And that's what it makes communication possible among the services if they need to talk. And if you need to talk outside your cluster, then ingress and egress gateways you need to have. That's what also you can configure in the service mesh. But the most important of it is the control plane, which is the brain of service mesh, where it gives you all those features or the pillars we just spoke about, and that's what enables the data plane to do rest of the features on top of this layer. Now, important thing to note here is that service mesh is important if you have east-west traffic primarily. If you have only north-south traffic, maybe service mesh is not the thing for you. But if you have more of applications, microservices talking to each other, then yes, east-west traffic, majority of it, though in real situations we will have north-south traffic as well, but primarily you should have east-west traffic. With that said, now, like any other technology with open source, it's rapidly transforming, rapidly evolving. We have seen that there was a time when we were all on monolithic architecture. Then we quickly jumped into microservices architecture, and more clients started talking about what is microservices architecture with the Kubernetes, and we started building microservices for them. That's when the need of service mesh was identified, because Kubernetes was taking care of the life cycle of services. It was not enabling us with the communication between those services. And very soon, we went into a world of multi-cluster, multi-cloud, to hybrid cloud and edge use cases. Then if you have multiple service meshes, then you need to make them talk to each other as well. So you have service mesh interoperability. And now, now we are talking, there are many other features which are getting cooked up with the service mesh. Some of them are like ambient mesh, granular filtering, more enablement of service, serverless, etc. So with this rapid evolution, let's go into an enterprise case study, because theory and evolution are best put to practice when you have something implemented. So let's look into a case study which should give you insight into how it gets implemented in the hybrid environment. This is a case study about the telecom industry, where the need is cloud modernization and microservices architecture. And the business problem statement is, how do we unlock business use cases and make services talk to each other, which is spread across the hybrid cloud? That's when what we wanted to do, imagine these 4 colors in this are 4 different infrastructures. And this is the reality. I mean, whatever cloud world we are in today, but the reality is hybrid cloud. And we wanted to make all these 4 different infrastructures, networks talk to each other, and rather than going haphazard manner in this way, we wanted to go service mesh route. So it was early on identified that yes, a service mesh is a case for us, and we want to go with that. Now, that's where we started our work, and this is one particular use case which I'm sharing with you. So starting from the rightmost, where my user has a need, and he wants to do his mobile charging with some prepaid package or postpaid package. That's where he SMS to the telecom company, and it hits the online charging system to do the charging, whatever has been requested. But online charging system, which is one application, cannot do the work in isolation. It needs to talk to your customer resource management, which is here. And customer resource management need to validate whether, as a user, you can do that kind of recharge or not. So it validates it. Once it validates, then it goes to billing system to do some whatever billing related stuff needs to be done, and it deducts the amount or takes money from your credit card or whatever. And then user gets this information back that whether your charge is successful or not. Now, this is a very simple case in telecom industry, but interesting thing now is these three were running on three different infrastructures and computes. This particular one was Salesforce Cloud, which was at that point in time was not Kubernetes supported. Next thing, we had AWS Cloud. Billing system was more and more getting developed on the billing system. And that's where it was running on the Kubernetes AWS EKS. Next interesting flavor we had was on-prem VMware infrastructure, but it was thankfully running on the Kubernetes, managed Kubernetes by VMware. So we had to bring all these things together and enable the services mesh, which we were trying to create. A lot of challenges. Let me go into challenges along with the decisions and what technology we took. First and foremost, the challenge we faced was hybrid infrastructure with or without Kubernetes. Now, when we picked up this case, service mesh was not supported for non-Kubernetes or non-container orchestrator platform. So the decision we made at that point in time that we will go ahead with Kubernetes-enabled clusters for service mesh enablement first. And non-Kubernetes-enabled workload were taken on the API gateways, and we were still communicating, like I showed you, Salesforce Cloud. We had customer resource management there. Then technology-wise, though we evaluated AWS App Mesh, VMware Tanzu, but those were not mature at that point, so we went ahead with Istio Service Mesh, which provided us Envoy proxy, which enables it with a lot of good features at the back of it. And Google APG was used for the API gateway. Next comes the challenge number 2, inefficient service discovery and routing, which I think with the selection of Istio and Envoy, it helped. And Istio provides you a lot of configuration, which you can play around with and do the fine-tuning of your system, that how do you want to really do the service discovery and routing and traffic control and whatnot. Next challenge, connectivity challenges with service mesh, achieving north-south and east-west traffic. As I said, we went with the east-west traffic more. Ingress and egress gateways we used everywhere for enabling our east-west traffic. And only exception was non-Kubernetes workloads, which were enabled on APG, and that's how we achieved our north-south use cases. Envoy proxy and Istio gateway were configured and utilized. Next comes teams, new for Kubernetes as well as service mesh. Now, how would you tackle that? There was a decision that we will start small with couple of clusters, and those clusters which are non-critical and Kubernetes enabled. So we went ahead with them, and then we slowly brought in other non-Kubernetes cluster later in the picture and critical workloads later in the picture. One thing which really helped us was the global control plane, because global control plane decision really helped, because a small group of people need to know about those fine-tunings, configuration, and things in and out, whereas developers and other platform users need not be worried about that. So that really helped, and we'll be double-clicking on that in further slides. Last, limited to no observability. Here also we went lean. First, we went with the Istio provided Kali and Prometheus-based observability. And then we went ahead for the long run for Prometheus, Grafana, and other cloud-provided services. Last but not the least, one of the favorite topic all time for security groups, that TLS version differences. So bringing all systems, decision was to bring all systems to TLS, because we had this issue that different systems were running on different TLS versions, so there was no question that we can come to MTLS at that point in time. So we went ahead with TLS 1.2 or higher version enablement, and then later we went for the MTLS enablement. With those challenges, decisions, and technology out of the way, this is how the architecture looked like. You have a couple of different hybrid cloud combination infrastructure there. Istio and Kubernetes was there. On top of that, as I said, we brought things into global orchestrator you call or central control plane. That's where our different clusters running on different infrastructure came together and we were interacting between these services. For those cases where you have APG was used for communicating with north-south use cases, as I said, or for communicating with non-Kubernetes workloads. Now, this is the big picture, but what is happening inside that pod? Where is my service mesh? So here is my service mesh in each of my clusters, where what is happening here is if any service needs to talk to each other, let's say I have a service in cluster 1 on AWS, wants to talk to another service in cluster 2. Then through ingress and egress gateways, they were talking. And of course, these were having their sidecar proxies, which were doing the magic. And a lot of policies were enabled so that things are in control, and it was security enabled as well. So this is the internal look of the cluster. One thing which I want to explicitly mention again, that global orchestrator really helped us in bringing this hybrid cloud beast under control. And configuration, isolation, observability, identity management became easier for doing it for first time, policies, regulation, and traffic management. So this is how my big picture looks like for this use case. Now what I want to do, shift gears a little bit. Now what's in it for you? How you can use the learnings which I'm sharing here. In order to do that, let me give you a glimpse of the decision-making framework, not just based on this case study. I'm trying to put my all learnings together here and giving you a framework which you can reuse in your systems if you're planning to consider service mesh, or if you're already using, then maybe some learnings hidden there for you. First thing first, I'm going a little tangent here, but first thing first, do you need service mesh? Not in all cases you need service mesh. So please consider, and I'll be talking about it in a little more detail, that how do you decide, do you need service mesh or not? If you do, let's say in your case you do, then start in this spiral manner. Start with the network topology and architecture first. Be very clear, how does your network, your architecture should look like, how much network you have, how many services you have, how do they connect. Once you have, and somebody was highlighting in this room in previous session that design is one of the main aspects where platforms fail, things fail. So start with this. You may not be able to build it in one day, but have that picture clear that what is your estate looks like, how's your enterprise is laid out today and where it is moving in future. Once you have this covered, then definitely security. As I said, nobody will allow you to go to production without security. So it has to be built in. And it's a pain and a pleasure. I don't know I should say it or not, but yes, you will have to take care of security a lot. Services design and observability, yes, the fine-tuning part comes here, that how would you do the services designing, testing, etc. And then comes your developer and platform experience. So always start with strong foundation here and move for the abstraction for the experience and experiences here, there. Now, how do you decide that do you need a service mesh or not? If you have microservices-based architecture, if you have API ecosystem around, if you have high service-to-service communication, majority of your traffic is east-west traffic, and you are container orchestrator enabled. Now we have service meshes where they also take care of your VM-based compute or serverless compute, but still majority of your workload, if container orchestrator enabled, then it will run beautifully for your organization. So with this, one more thing you need to decide early on is, do you want to go with the service mesh which is self-managed? For example, Istio and Linkerd are two popular ones, and most of the managed service meshes out there are using Istio as the base. And it provides all these features, but it comes with the open source releases, which you would need to maintain on your own. But if you want to go fast and you are clear that you are ready to pay, then there are managed service meshes, which provide you a lot more features on top of it, but they come with extra cost. I don't want to name any specific service mesh here, but there are many out there. Now, it's clear that you need service mesh. Let's assume those were the decision points. Now, how do you decide on your network topology and architecture? There are a lot of questions to answer there to decide on your mesh model and topology. First and foremost, look at your infrastructure and clusters, which unfortunately, very simple point, but we don't look at it. We get so much absorbed in the complexity of service mesh, adopting POCs and all that, that we don't look into this aspect. But it's very important that over the period of time, where you are heading. Do you have one cluster? Do you have many clusters scaling in the future? Do you reside your majority of your infrastructure on public cloud, private cloud, or data center, or a mix of all these? Then comes the second point. What is your network look like? Is it like one network which is having multiple services running? Or is it like this, where you have network 1, network 2, and you would need to talk to those 2 different networks? If there are different networks, then you need to also plan for gateways, that how and where you will be placing all those gateways so that they can seamlessly talk to each other. Then comes the control plane decision. It's, according to me, one of the most important decisions. We should decide that whether we want a single control plane, or we want control plane in with every cluster, or we want control plane in distributed in such a way where west side we have one control plane and east side is handled by another control plane. There are various combinations possible. You should think and decide that which will work based on your use case. Let's say if that's taken care, then the last thing I would highlight here is the namespace or the tenancy decisions which you should take. Whether you want to go tenancy team-wise, where let's say this particular case is a team 1 a namespace spreaded across. Namespaces or the tenancy decisions help you with the naming conventions, the service discovery, and those things you can do easily. But if you have different teams, for example, in this case, BU1, BU2, and you want to segregate them based on the business units. So all this put in together, you have taken care of a lot of these questions. Then you will have your own picture. For example, in this case, what I'm putting it is for my use case, where we had 2 networks, network 1 and network 2. We also had one mesh which we laid out, one control plane which we decided. We went with Istio. We had couple of gateways to interact internally, and we were having one external gateway, API gateway, which was utilized. So this kind of picture, believe me, once you have it somewhere, just keep it, maybe not keep referring it, but it helps a lot. Next pillar or the next circle which I had in my framework was security. Now, security itself is such a big topic, cannot be covered in half an hour even. So I'll be just touch basing on that. One important thing on the security you need to take care is how would communication or encryption, authentication of these services, because every service needs to prove that, yes, it's a valid service of that particular mesh, and it talks with the other service which is encrypted, and as I said, MTLS or TLS, whatever you want to go with. But certificate authority then works with your control plane and issues those certificates to these services, using which then you can talk to easily within the service mesh. Now, it becomes complex when you have multiple meshes. That's where, let's say, if this is domain 1, you should have trust bundles exchange between these meshes, and then you can achieve it. I'm linking here a talk which you can go through. That gives a lot of insight into how PKI and certificate management can be achieved. Last thing in this I want to say is the service design, visibility, and testing. It's a lot of things, but let's say if you have service mesh, we want to keep it invisible road, right? We don't want to have proxies injected where developer knows about it. So you need to be doing it in such a way whenever you are introducing a new service, you are deploying something, it should be invisible to the developers how my proxies get injected into the system. And when I'm injecting those proxies, it should not happen that my developers have permission to those and they can do anything. They can delete the service sidecar proxy. So all those things you would have to build into the system. Observability you will have to decide. And one thing which I want to highlight here is mostly what we do cluster-wide visibility. We show beautiful Grafana dashboards to our management and say that, see, observability is here, but that's not the observability. When you really achieve it, because Service Mesh is providing you that capability, if you're giving the business-wide visibility, then I would say that you can call or qualify it as real observability or distributed tracing. Lastly, it's a mesh after all. So do your chaos testing, do your performance benchmarks, and then be satisfied that what you have put in place will work in difficult situations as well. Now, this is the time when you should start thinking about your platform and developer experience as well, because it doesn't get outside of the box. These are the situations where you start baking in, and baking in is the word which I really like, because you need to do it seamlessly. That's where the developer and platform experience can be brought in. So bringing it all together, always start with the network topology and architecture and go with the experiences for the service mesh. Now, my concluding thoughts here would be, like any other transformative technology, service mesh is truly a journey. And I would say be like my sailor here, who's embracing this journey, leaning into today's challenge, but he's forging a path and a direction which is his North Star and moving towards that. So similarly, if you're just using service mesh and not leveraging it, it's not fun. So harness the full potential, plan it well, and if you decide to go that way, then do it and use the full features of service mesh. With that, I'll say thank you. Thanks for listening patiently.